A good tool changes the way you work. A great tool changes the way you think. And I think serverless containers are the tool that has the potential to change the way you think. Today, I'm going to talk about serverless containers. The title is long. We had some issues trying to do the title up. So anyhow, let's see how this goes. I am Geshan Manandhar. I call myself a tech service provider. I'm a senior software engineer. I've been at GE for Google Cloud Platform since 2019, and I've been blogging since 2007. You can find my blog there. If you want to follow the slides, you can scan the QR code with that line between. Probably that would be something. There will be a couple of things that will be helpful if you want to follow the slides. I'll probably pause here for a couple of seconds. Yeah, go on. So I'm from Kathmandu, Nepal originally. The only country that has non-rectangular flag and has 8 out of the 14 highest mountains in the world. In terms of relationship with Australia, because of all the students going in, it's helping pump billions of dollars to the Australian industry. I work for Simply Wall Street, so we basically help individual investors make long-term better investment decisions. We visualize data from around 120,000 companies, stock data, basically, of 120,000 companies around the world. And if you are into investing, research, you can have a look at Simply Wall Street. The things that we're going to cover today, I'd start with what serverless is and why use serverless, then go into containers and why use them. Then there's a bit of discussion of the current function as a service offering, like the relationship with it in the cloud spectrum with ease and control. Then go a bit into Google Cloud Run, the serverless container part of it. I did a demo in the morning, it had some issues, so hopefully I did show a video. I don't know if there's some issue with the Google Cloud Console, at least for me today. And then towards the end, I'll mention a couple of projects that actually use Google Cloud Run in the world. So what is serverless then? Serverless, at times, it's focused on functional service only, but I think serverless is greater than that. Basically, Mike Roberts from Symphonia says it's a fully incorporated third-party cloud-hosted application and services, which is also called backend as a service. For instance, you could take your S3 as serverless as well, because you're not managing any service, you're only paying by what you're using. So that can also be considered serverless. Similarly, the main concept or the main thing that has been pushed out towards for serverless is function as a service. And what that is it runs in a status compute container that are event triggered, ephemeral, and fully managed by the third party. By that I mean we're talking about your Google Cloud function, your function, and your Lambda. So that's basically function as a service where you pay by the usage. Now, if there is a reasoning, let's have a look at why use serverless. So some of the reasons that you want to use serverless is, first, there are no servers to be managed by you, not necessarily no servers, but you're not managing them. And then it is very precisely based on cost. For instance, if you have a lot of traffic coming to your website, you pay more. If you have no traffic coming to your website for the whole day, then you basically pay nothing. It's 5 seconds.
You can continue.
Yeah, okay. Yeah. It's inherently scalable by that if you get a lot of traffic, then the number of functions would scale automatically. Generally, one function or one service function only handles one request. So if you get a lot of requests, it would scale automatically. You can have a lot of load, which makes it highly available. There's less things to worry about. It will automatically scale and be highly available for you. In terms of functions, it's very easy and quick to deploy. Basically, you throw your code over the wall, and it's the cloud provider that's managing it. So that makes it much easier to deploy. And then, reaching to a working URL or working application is much faster with serverless, any form of serverless actually. And that basically reduces your time to market, which gives you an advantage if you're Now, the main thing with serverless, any form of serverless, is that you focus more on the code part of things, and you don't really need to worry about the infrastructure, because that's what you're basically offering and giving it out to the big guys, like let them handle all the infrastructure, all the scaling, and you can basically focus on your application, which is the piece of the application. In terms of serverless, the big three clouds have these three offerings. So you can run Node, Go, Python, and all of these things on Google Cloud Functions. And then if you're using Lambda, your function would have a maximum execution of 15 minutes, whereas on Azure it would run for 600 seconds, which is 10 minutes. And then the main thing here is your function could be triggered from multiple event sources, S3, of course. And then let's say someone offers a file in S3, could have a function that would reset the file or do something. So a lot of things can be event-based as well for function. One thing that you notice here, they basically have a predefined set of languages you can use. And that's a good thing as well as a restriction that is part of functional service function. So if you look at some analysis by Gartner from 2022, they say that serverless PaaS has reached the slope of enlightenment. So basically, it's a good time to adopt serverless functions or serverless PaaS now. Similarly, serverless infrastructure is also kind of going into the scope of enlightenment. So it's a very good time to use services. Basically, what they are trying to say. Now, thinking of servers with serverless, there are still servers. The only thing is you are not managing them. Someone else is managing them. And that's what this particular Gartner by Forrester tries to say that, yes, of course, there are servers, but the only thing is that you are not managing them, someone is managing them. Now, coming into the realm of containers, what are containers? Containers, as per Docker, which is the most popular container technology, Docker says it's a standard unit of software that packages all code and all its dependencies to a single package. That is basically what a container is. What you're doing is you're basically, now if you go into the why it's using containers, what you're doing is you're basically shipping the whole stack of the application. By that I mean your operating system layer, your language runtimes, like a third party, and your own code as well. So whenever you do a new deployment, the whole thing changes. For instance, let's say if you are using something like Abstract, what you would change is only the third-party code and your code. The other things would still stay the same across all your deployments. But in case of containers, for every deployment, basically working clean and then put the whole stack. Now, what that does is it helps with reproducibility. Whatever works on your machine, 99.95% of the time, would work on staging and production as well, because what you're doing is you're not just replacing the code, you're basically replacing the whole stack. And with that, it is much harder to have problems like I'm using Node shell on my local machine. The server has Node. So I'm using Node 10 on my local machine. The server has Node shell. So there are going to be problems. But if you keep the whole stack, both of them are of course going to be 120, and then you have a lot less things to worry about. It's a lot easier to scale horizontally and has a faster initialization. For instance, if you run 50 virtual machines on your Mac or your local machine, basically it will die. But even if you run like thousands of containers within one object, it is going to work. So making it work because it's very fast to initialize and execute. That's a good thing, as well as it can scale horizontally a lot easier compared to, let's say, a virtual machine. And with the usage of and popularity of Kubernetes, it becomes a lot easier to have either a multi-cloud strategy or even to move clouds. Because at the end, what you're doing is you have the containers, they are being run with Kubernetes, right? As long as you have a flavor of Kubernetes from any of the clouds, you can potentially move your workload around. But as much to the data, that's a big question. That's not that discussion. But with the uses of any flavor of Kubernetes, even moving clouds or having a multi-cloud strategy becomes a lot easier. Last but not least, it makes the developer side of things much more productive. For instance, you just clone 3 or 4 repositories, run a compose of command, and I don't know, like 15 minutes, grab a coffee, and your whole platform or your whole stack should be working. Which compared to, let's say, a VM or older technology much have been a lot difficult. You need to do everything one by one and make sure that all the things talk together. But with containers, it's kind of much easier to lay out. And then what all of this does is it basically decreases the your distance between the developers and the operations, which is also called SRE or platforms engineering these days. What I'm trying to say here is, like with containers, it's a lot easier because you ship the whole stack. It's the same thing running in your local staging and production. So it becomes a lot easier, and then an ops don't have that going over the wall from that, because at some point you might go into you build it, you will run a kind of a engine. But yeah, if you think of this, these two camps of serverless and containers, they have been kind of fighting for a while now. Even if you go to Google and type serverless containers, it will add a versus in between those two words. But yeah, I mean, rather than making them two tribes, this particular talk is more about building a bridge between these two tribes and getting the best out of both worlds so that it will help your business propel forward. Now, thinking of serverless and container evolution in the cloud, as I said, they basically started many years back with virtual machines where people used to have boxes, basically speed boxes, very powerful machines, and to slice them up to do multiple things, they started doing virtual machines. From there, I think it was 2003-ish, 2010-ish probably, that the serverless functions came into play. Lambda was the first by AWS to actually give us serverless functions, which gave us a lot of ease and abstraction. But with virtual machines, there was a lot of control. You could slice the machines as you wanted. You could go into the machine with it and do whatever you want. But compared to SaaS functions, you basically throw code over the wall to the cloud providers, and they run it. You can't really go into that machine and then do some research or do any other configuration. Basically, like send your code, let them run it, and most of the times they go to check about it. Then came PaaS, platform as a service. I think one of the first ones was Heroku, which basically popularized this PaaS concept of give us your code, we'll run it, you'll have some form of control, but basically all of these because we are managing it. I think the downside of that is Heroku at one point started charging a lot, and then it's sort of more competition. And yeah, that's PaaS. Then around 2013-ish, containers came into play. Containers are not a completely new thing, but Docker kind of democratized it. So a lot of people started using containers, and yes, with containers you have a lot of control, but then you give out on the ease and the abstraction part of it. By that I mean, like, you could get it into a container and do all of the things. You could have root access to a container and do whatever you want. Now, the thing that sits in the middle here, which I think is the sweet spot, is when you do serverless containers. So you have the control of your containers, as well as, because it's serverless, you have the ease and abstractions of serverless, because those containers are managed by one of the big three clouds, or in this case, Google Cloud. And that's where we enter into Google Cloud Run, which is a managed compute platform that automatically scales your stateless containers. As long as you can containerize your app and even put it with a build pack and send it to just deploy it in Google Cloud Run. Google Cloud Run will manage the running and the scaling of it. So that's where it becomes a lot easier that you, as long as you containerize, getting deployed in Cloud Run, you give all the responsibility to Google SREs to run that and scale those containers. So you of course need to set the configuration, but then you don't need to think of, okay, I get a lot of traffic. Now I'm getting a lot of traffic. I should be running 20 containers in place of 5 containers. That's basically managed by Google Cloud. Now, some of the reasons to use this would be you don't need to learn a new paradigm or framework. For instance, with a function as a service offering, at times you cannot just lift and shift your application into a function as a service. As I showed that it has some limitations as well, for instance, the size of the code and stuff like that. So that's where with Google Cloud Run, as long as you can containerize your working current app, that's it. You can run. The other good thing is you can run any language, framework, binary, anything you want. As long as it can be containerized, it can be run. I've seen people, like for the test, running mobile apps on Google Cloud Run. As long as they could be containerized, it could be run. Recently, there was a video of someone running Rust on Cloud Run. I think that's not a difficult thing. But let's say if you're a Rust programmer and you want to run your code as in one of the functions as service, good luck with that. I don't suppose any of the functional service provides that particular runtime, right? Yeah, the other good things is it is serverless and fully managed. By that, I mean, if you don't get requests, then the number of containers would scale down to 0. That means you're paying nothing. And even Google manages it, you don't really need to think of, for instance, the version of Kubernetes or the version of configuration that you use. As long as it's deployed as containers, it would be scaled out with the traffic and the resources that you configure. Yeah, you also get like SPC URLs out of the box. So as long as you deploy, it gives you a URL you can start using. It's not a very pretty URL, but yeah, it shows a functional URL, and then you don't need to handle with all of those ISL configurations and those certificates you get SPSs out of the box. You could even wire up your own custom domains to Google Cloud Run. We haven't doing it for at least a couple of side projects. I'm going to mention that later, but having your custom domain go into your Google Cloud Run service is very easy. It's just part of it in Google Cloud Run. With all of that, the other big advantage, in my opinion, is you can actually leverage all of the Google Cloud toolset. For example, you can build your containers with Cloud Build. As soon as you deploy your containers, they are automatically logging to cloud logging on Google Cloud. So whatever you send out on your console, that's already being shipped to cloud logging. You even get cloud traces. For instance, we have 20 URLs and 2 of them are slow since from yesterday to today. All of that is given free out of the box. You don't need to configure anything. And then there are other Google Cloud services you could easily use or integrate with Google Cloud Run. That's also a very good advantage of using Google Cloud Run. Some other amazing features that Google Cloud Run gives is, let's say you have a running app, right? And then you want to deploy a new version, but you deem it to be a bit risky. What you could do is you could deploy the code, only get 2% of the traffic to this new code, and then see. If the logs and everything look good, then you could increase it to 4, 10, 20, 50, 100, whatever percent you want. This type of gradual release, if you want to do it with something like Kubernetes, you need another layer that actually handles it. But with Cloud Run, it's all built into the interface itself, so you can do it easily. Same thing with concurrency. If it's a function as service, by default, it's one request, one function, then it dies, right? And with Cloud Run, you could configure the concurrency. So one single container could take up to 1,000 requests. That means the cold start problem is reduced a lot, right? So all of these are very good features of Cloud Run. If you want, you could go unserverless with Cloud Run. That's pretty easy. You have a setting called minimum instance. If you set it to 1 instead of 0, that means at least one container is always running. You have one container always running, that means you're paying for it, but then you have unserverless out of the services of Cloud Run. With newer features like jobs, integrations, and sidecar, like these makes Google Cloud Run even a better option to take. For instance, if you have a clone job that needs to run every day at 2 a.m. and takes 3 hours, that's possible now with Google Cloud Run. It's just a job, it's scheduled, and it will run till it's done. It's not going to time out in like 15 minutes, like one of the serverless functions that I have. Same thing with integrations. You can integrate with other Google Cloud Run services, other Google Cloud services, and then you can also utilize things like sidecar containers. Anyone who's used to sidecar containers, they could be used to like ship logs or do other things. Now, I mean, Google Cloud Run also gives there are good advantages. For instance, if you want to do a full-on CI/CD, you could use the whole Google products that are available, and then start doing it. As I said, build packs. If you don't want to explicitly containerize your app, you could just use build packs, and then Google will build it into an artifact that could be run on Google Cloud Run. Similar things with like health checks. They have added health checks now, monitoring and logs. All these things just come out of the box. So at the end, it's more like serverless and containers are kind of made for each other for your this. It's a lot easier as long as you can containerize your app and then put it on Google Cloud Run. Google basically handles the running and scaling of that.
I had actually tried this in the morning, but it didn't really work. So what I'll do is I'll just play out a video. I don't know what was the issue this morning with my Cloud Console, but my example was not working. I can see through what's happening.
So this is a basic GitHub repository where it's a Node.js application that is connecting to a Postgres database. And the only thing you need to do to try out Google Cloud Run, even if you have a Docker file or it's a runtime that Google Cloud Run understands, is you click it and you just kind of trust the repository and then say confirm. Yeah, then it takes a bit to create the particular machine. You authorize it, and then after that, you select a project, one of the projects in your Google Cloud console. I should select a test project if I remember this correctly. Actually, okay. So and then it starts enabling the needed APIs for that particular project. And
what happens after that is it is going to build the container on its own. Like the script knows that how to do that, looking at particular files.
And once it builds the containers, it's going to push it to the container registry by its own. And then it's going to deploy it as a Google Cloud service, which is going to come out as the URL.
Yeah, so at this point, it's just cloning the repository. It does that, and then now it's already pushing the container. There's a Docker push there.
Can you get it full screen on the bottom right?
Sorry, thanks. Yeah, sorry. Yeah.
Yeah, now it's pushing it and then it's deploying it to Cloud Run. So after some time, it's going to get the URL from Cloud Run, which I was talking about, which will be a CPS URL. Yeah, I was trying to do this in the morning, but I don't know. Like, there's some issue with my Google Cloud Console. Yeah, so as I said, this is all based off of Docker file that I was talking about. I'm not training Docker file, and the only thing I did was to click the button. So what we're expecting is to get that particular output. And yeah, it has the particular URL. So if we go into the URL, that should be running, number one, and then if I do a slash, it's on top of it. It's basically getting the codes from the database, and
that's how easy it is to actually deploy a service with Google Cloud Run.
Now, probably this will not work for continuous integration processes. So if you want to do that, you just have a Google
Cloud build.yaml file, and then yeah, you could do your full CI/CD on Google Cloud Build and get it running on Google Cloud Run. Yeah, so
I have run a couple of side projects with Google Cloud Run, one of them being which is a expert Twitter bot that has 10,000 followers right now. It gets used from multiple sources. What it does is it actually goes either scrapes them or receives the RSS feed and then pushes it to so that is already running on Google Cloud Run. And another side project that we did is called Data Jobs, which should be pretty exclusive to people for jobs and for the current market economy. Which what that does is it aggregates jobs from like 70 plus 80 plus companies and then puts it into one place, which is go in and see all the jobs, basically tech jobs that you want to look into one place.
And yeah, one of the other projects, which is not a side project, which is still a bit in development, is called OHC Guide, and that is also fully on Google Cloud Run. So what I'm trying to say is you could potentially start your startup on Google Cloud Run without problems. Now, those were smaller side projects, right? Even hyperscalers, really big companies use Google Cloud Run. And all of these are examples from Google's website itself. So Mailchimp, as you might know, which used to send a lot of emails or transaction emails as well. They basically say they have the ability to put an automatically scaling service in production, which is one command which is very effective for them. Similarly, BBC said that once they were running like around 150 to 200 containers, and they had to scale up to 1,000 or more containers to process their logs. This happened at the time of the Queen's demise, and everyone was trying to like get to BBC to get the news. So basically, their traffic shot up. And with Google Cloud Run, they could process like 3 billion log lines in the same day because it scaled from like 100, 200 containers to over 1,000 containers. I won't say almost instantaneously, but as per the load. So that was something that Google Cloud Run could do for them. Hermes, which is infrastructure for delivery and things, or as for operations, yeah. So they could be like 99.8% of their business on this Google Cloud Run. They have over 30 microservices running for them. So they could, like, customers could easily send and track their deliveries and find the battle shop. So in addition to these, companies like IKEA use it. So if Google Cloud Run can handle IKEA and these kinds of scale, it can surely handle the scale of your startup. I guess that would be it. I'm pretty early. That's good. Open to questions. If you want to follow me on LinkedIn, that's fine. Thank you.
Just a clarification more than a question.
Go ahead.
Right. So Cloud Run is really your deployment infrastructure. So the containers, so Cloud Functions and Cloud Functions with a container built in is really running in the Google infrastructure. So where you've got your 1,000 container or your 1,000 functions running, that's not really Cloud Run running it. Cloud Run manages the setup of it, but then it's the Google infrastructure that's delivering the service.
Exactly.
So that the value of Cloud Run is that repeatable deployment mechanism where you can have a configuration and deploy it repeatedly and quickly. So it's all one big infrastructure, but the Cloud Run itself is really what's managing your deployment and your configuration of it.
Yes, like from another point of view, what I would look at it as is you could basically run a pretty popular app without a single DevOps engineer in your team, right? Because you are not managing something as complex as Kubernetes. So that basically gives you an interface as simple as this. And as I'm speaking and I have time, what you could do is, you could say this, and it's as easy as this. If you set this to 1, it's not serverless anymore, right? Because one instance will always be run. This makes it serverless. It's as easy as to go serverless or not, right? And this is like the number of maximum pods or instances that you would like. If the traffic goes up from 0, it's going to scale up to 100, depending on how many you put it here. I guess you can go up to 1,000. Really? Nice. I didn't know that. Okay. So and then all you need to do is like this. You say it could be accessed from anywhere. Hello. Okay, nice. And that's about it. It'll take a bit because I'm using a test container. It's just gonna go in and deploy. Like what I did showing in the video demo is basically this with script, right? So actually, what it's doing is doing this. It's just going in and given the container is already built and pushed to a container registry, pulling it from there, deploying. That's it.
The first example you showed, for those who don't know that is a shell running in the console, and it was great. So it was giving you a shell which was doing the deployment.
Exactly.
Whereas this is using the UI interface to deploy.
Yes, which is part of the whole process because the shell was actually getting the code, building the container, pushing the container to the container registry, and then deploying. What I showed you was just the last part of actually deploying. But from a UI and user's point of view, as long as you understand containers and like building and pushing containers, it's easy. Sorry, go ahead.
I was going to ask, in your experience, how reliable is it? Did it just know that you can do a demo and then there's a break this morning?
Generally it would work. This is the first time I'm showing the backup demo. I've done this talk like 4 or 5 times by now or even more. And this is the first time. I don't know what happened. I think it's some configuration or something on my end because I was using it in an incognito window. I don't think it was anything on Google's part, but as I said, I just tried in the morning to see if it worked. It did not, and I didn't want to take the risk.
The process is super reliable, so you can rely on it 100%.
Yeah, I assume it's because I am using my incognito window. It has to do something with that, or yeah, probably somewhere there rather than because I also look at the Google Cloud statuses. They are not reporting any bugs, so it should be something on my user or the way that I'm using it, something there, which it was in the morning and I didn't want it to debug.
Cheeky follow-up question.
Go.
TCP. It's a bit, I guess, like relatively new to AWS. Azure, it's not new.
Go.
Do you find there's anything kind of lacking as it tries to do the services up compared to the other offerings? It's pretty much.
It depends. So now, how I would look at it as market share. So Google Cloud is probably the third in terms of market share with 12 to 14% of the market, right? That keeps it at a very good place, I would say. Now, in terms of features, if you want a serverless database, probably Google Cloud does not really have that out of the box, whereas you could have Aurora on AWS or some other flavor on Azure. I don't know much about Azure. So except of that, at least for the things that I'm using, everything's there. Like everything I need is there. And the better parts are like the DX compared to the AWS UI. The Google UI is a lot more easier to use, and services like these are a lot more straightforward because a comparable service to this would be Amazon's Fargate, which is a pain to use to say the least. So yeah, and compared to that, look at this. Like as long as you can build your containers, you're not deploying it on Kubernetes. You're on Kubernetes. Run 3 clicks. Done.
But you also have access to multiple database. You know, you talk about cloud or serverless databases. You can configure one of multiple different types.
Yeah, I mean,
of
like
data
if I really want to go
storage
into
behind your container. So,
exactly.
and we'll see with the Firebase stuff.
Yeah, exactly. Firebase and like if yeah, go ahead. Sorry.
You've got multiple options.
Yeah.
AWS, Azure, and
Yeah.
so it's
Yeah, as I said, if I wanted to really do like a serverless database and say serverless Postgres, I would just use this service at this point, which is an external service. But yeah, the thing is, I want to go fully serverless. I don't want to pay for my database when it's not used. This fulfills the job, even though it's not inside Google Cloud. But yeah, I mean, I get
Google Cloud has serverless Postgres, MySQL, and Microsoft SQL. But I mean, they are paid services. But
no,
Google
Cloud has Cloud SQL, which is not serverless as far as I know.
Right?
No, they're not serverless because if you
how do you define it's not serverless?
if you turn on the database, you start paying for it.
Yeah.
And that's not serverless.
Yep.
That's what I was saying. So, sorry, yeah, go ahead. Any more questions? Good.
All right, we're gonna figure out the forest for